Hello, namaste, and welcome to my next section of route packet forwarding and routing processes. So we have previously looked after a router paths and packet switching. In this, we have learned about destination IP addresses and other aspects of IPv4 addresses, including source and destination IP addresses, version TTL, and other fields. So moving on to the next chapter, we will find that the MAC layer format, the MAC frames are also divided into fields. They include preamble, startup frame delimiter, destination MAC address, source MAC address, type and length, data and pad, and frame check sequence. We call it APCS. So this is the Mac layer frame format. As we discussed earlier, this is present in this frame format. Okay, a metric is a numerical value used by routing protocol help determine the best path to a destination. The smaller the metric value, the better the path. Two types of metric used by routing protocols are hop count. So 1 to 3 hop or bandwidth. Let's suppose T1 of 4 Mbps and this R1 to R3 of 56 kbps. So this is the bandwidth. Hop count. This is the number routers packet must travel through to get to its destination. If this wants to go to this and if it's using a R1, R2, and R3, then there will be a 3 hop. Bandwidth. This is the speed of a link, also known as the data capacity of a link. So here the data capacity is 56 kbps, whereas here is the T1 link. Equal cost metric is a condition where a router has a multiple paths to the same destination. Okay, if this PC wants to go to this PC, then this PC either can go from this path or can go through this path. To solve this dilemma, a router will use the equal cost load balancing. This means router sends a packets over the multiple exit interfaces listed in the routing table. So what does this does? It calls the load balance. Let's suppose this is 50% and this is 50%. The traffic would move from both the path 50 by 50 or maybe 60-40, 70-30, or vice versa. Path determination is a process used by a router to pick the best path to a destination. One of the three path determination results from searching for the best path. Directly connected networks, remotely connected networks, or no route determined. Switching function of a router is the process used by a router to switch a packet from an incoming interface to an outgoing interface on the same router. A packet received by a router will do the following: strips off layer 2 headers, examines destination IP address located in the layer 3 header to find the best route to a destination, re-encapsulates layer 3 packets into layer 2 frame, and forwards a frame out exit interface. As packet travels from one networking device to another, let's suppose this networking devices to this networking devices, the source and destination IP address never change. You should always keep in your mind that the source and destination IP address never change as a packet travel from one networking device to another. So if the 192.168.1.10 source IP wants to reach to 192.168.4.10, then this source IP address and this destination IP address never change. Whereas the source and destination MAC address change as a packet is forwarded from one router to another to the next. Okay, for example, the source could be this MAC address and destination could be this, and source could be this and destination could be this in terms of layer 2 MAC addresses, but the source IP addresses and destination IP addresses will never change. TTL field decrement by 1 until a value of 0 is reached, at which point router discards packet. So TTL is something time to leap that will help router to endlessly traverse the network. Path determination and switching function details. Okay, PC1 wants to send something to PC2. For example, if this PC1 wants to send something to PC2, what is the step number 1? PC1 encapsulates the packet into a frame, and frame contains R1 destination MAC address. Okay, PC1 encapsulates the packet in a frame. It will encapsulate the packet into frame 192.168.1.0 into a frame. Frame contains the destination MAC address. So if this is the packet, then it will encapsulate into 010. Okay. Step 2, R1 receives Ethernet frame. Now R1, this one, receives the frame. R1 sees the destination MAC address matches its own MAC. Okay, this is the destination MAC address here, its own 010. R1 the strips of the Ethernet frame. R1 examines the destination IP. R1 consults the routing table looking for destination IP. After finding a destination IP in the routing table, R1 now looks up the next hop addresses. So here we have a routing table of 192.168.4.0 and the next hop IP addresses of 192.168.2.2. R1 re-encapsulates IP packet with a new Ethernet frame and R1 forwards Ethernet packet out of fast Ethernet 0/1 Ethernet. So it will now forwards the packet into the next hop address of 192.168.2.2. So the step 3, okay, the step 2 we can check here. B031 is the next hop frame the router will send. R2 receives the Ethernet frame. Now this R2 will receive the Ethernet frame. R2 sees the destination MAC address matches its own 0B31. Okay, and R2 then strips off the Ethernet frame. R2 examines the destination IP address. R2 consults the routing table looking for destination IP. After finding destination IP in routing table, R2 now looks up the next hop address. So for the R2, the next hop address will be 192.163.2. R3 receives the PPP frame. Now R3 receives the point-to-point frame. R3 examines destination IP because this is serial link. So R3 consults routing table looking for destination IP. Destination IP is 4.10. After finding destination IP in the routing table, R3 directly connected to destination by its fast Ethernet 0/0. Okay. R3 encapsulates IP packet with a new Ethernet frame. R3 forwards the Ethernet packets into fast 0/0. So step 5 would be IP packet arrives at PC2. A frame is decapsulated and processed by the upper layer protocols. So whatever the upper layer protocols like application or the session protocols, then it will be processed. So let's talk about the summary. Routers are computer that specializes in sending a data over a network. So router is a kind of computer that will send packets over a network. Routers are composed of various things like hardware, CPU, memory, system bus, interfaces. Software is iOS configuration file. Router need to be configured. Okay, when you buy a router or purchase a router, then it has to be configured. The basic things could include router name, router banner, passwords, interface configuration with IP addresses and subnet marks. Routing tables contains the following information: directly connected, remotely connected, network address and subnet marks, IP address of the next hop addresses. Router determine the packet path to its destination by the following: receiving an encapsulated frame and examining destination MAC address. If the MAC address matches, then the frame is de-encapsulated so the router can examine the destination IP address. If destination IP address is in routing table or there is a static route, then router determines next hop IP address. Router will re-encapsulate packet with appropriate layer 2 frame and send it to a next destination. Process continues until packet reaches destination. Only MAC address will change, the source and destination IP address do not change. Always keep in the mind, this is very important thing, that only the MAC address changes as it travels from one network to another network, but the source and destination IP will never change. Thank you for watching, and I hope this session has been very informative to you, and I look forward to joining to another session. Thank you for watching. Have a good day.